Hey viewers, please check out Frontiers of Mind. Please support Professor Kastner and tell your siblings about it, tell your family about it, and inform the young generation about Frontiers of Mind because we need more people to know about neuroscience. And neuroscience can impact all different types of fields. It's not just science. So please check it out. You can improve yourself knowing more about the brain. So
yes, can I just say one more thing about that? It really can help you to understand yourself better. If you want to learn about memory, why you learn better if you have a good night's sleep. I mean, you can learn about so many things that are really relevant to your life, and you will understand why that is, and probably then also be a little bit more careful with what you're doing. So I think it's really, really a cool thing to start to understand what's going on up there.
Yeah, definitely. And check out brainfacts.org too. Professor Professor Casey and Professor Kastner both work at brainfacts.org. So please check out all the interesting information to learn more about the brain. I have a quick follow-up question about the trend. How can we fix our attention on one thing? Because I feel like as a student, going to school, it's really kind of hard to listen to a teacher for an hour and a half, and we got to take notes and listen to teacher. Knowing this curve, how can we improve it to focus our attention, not get distracted by other things, and really knowing the top and then the bottom and how it triggers these things? How can we fully focus on one thing and finish it as fast and efficiently as possible, knowing with your research with attention?
Yeah, no, that's a great question. And so before the pandemic, I used to give a lot of teacher seminars. So I talked to teachers about that because I think that, they can use this knowledge in the classroom. So in the first place, what it teaches us is actually that in our normal function, we have these ups and downs. So what we are basically asking our students to do in the classroom is to get into one state, and that is that up state, right? And then to try to stay in that state as long as possible to take in as much information as possible. But that is very tiring, and you know that. And it is tiring because you don't have your normal cognitive network function or attention network function, which goes that way. You have to get the network all the time to that level. It's very, very tiring. And so one of the ways to basically avoid that is to give breaks. So you can do that as a teacher by doing different activities, and some activities are require more focus, but then others require less, which means that you would basically get your network into this, and you can go by with that because you don't need that much focus. And then there will be another period where you need more focus. But you have to basically, if you are a good teacher, you go back and forth between those and not basically ask your students to be all the way up there. So I can give you an example from my own teaching. So I'm a college professor, so I do a lot of teaching as well. I'm teaching neuroscience, but it doesn't really matter. What I do with my students is I use a lot of video materials. So I'm teaching a lot of about clinical topics. And for instance, I use a lot of videos of patients. And then I engage my students in a conversation about these videos, what they have observed, and so on and so forth. And those are all kind of periods when they don't need that much attention. So their attention network is in that state. And then I go into a block of lecturing where they have to pay more attention. So they have to get their network more into this kind of upper state and don't switch that much, right? But I try to alternate that to give them, breaks basically from being up there all the time. And this is, I think, one way to address that. Not all teachers know that. We probably know intuitively that it's very tiring, to focus for very hard for a long period of time. But now we can say why that is, because what we really do during that kind of intense focus is that we switch off these network things that are normally there. We just switch them off. We just try to lock ourselves into the up state and maintain that state. And that's enormously tiring. But we cannot do that all the time. We just have to kind of take these breaks and go into this kind of rhythmic state again. So I think that's very, very important. So taking these breaks is an important part of learning, in my view. So, and again, you know, I hope that I can go back to talk to teachers about that, because they received that very well. Many of the teachers have reported that they have changed the teaching strategies after they learned these things about the brain and how the brain works, and then they have really good results with that. So there's a great amount that you know, teachers can learn and students can learn from neuroscience about how to learn best and what works best for them.
Yeah, and also I talked to Professor Daniel Schachter from Harvard, who does his research on learning and memory, and he also kind of talked about he tries to, I think one aspect of what he was doing was with the classroom, where he gave like, I think 4 multiple choice questions like each section of the lecture. So like he would speak and give a lecture, and then he would like give a 4 multiple choice, like I don't know, like a multiple choice test, and like some like tests in between, like 4 tests during the lecture. So like he kind of experimented that the kids were more focused like when he gave these like these little tests, because I think what happened was that like it was like this curve of attention, right? Like when he was teaching, they had their like this, like it started from them being in their low state to like peaking up. So I think he did a lot of research in that area, trying to improve like classroom learning. I don't know, but I've heard of something called blended learning. I don't know if that's somewhat correlated to this, but like I think I understand like how attention really does make a difference. So my next question would be, in the Mysteries of the Brain video, talking a little bit more about how your work can help the development of new advanced technology with facial networks and understanding human behavior, and ultimately having like a clear picture with what the brain can do. What are some of the things that you would like to mention that are fascinating about this part of your research area, especially with like new advanced technology with facial networks?
Let me think about that. So one of the most interesting questions, actually, a student of mine has pursued, not so much, that was not, you know, the work that we did ourselves in the laboratory, but I found that just very, very interesting, is one question that is very old, is whether face perception is innate. So we are born with it. We are born with the ability to recognize faces or process face information, and we are really good at that because faces look overall similar, but we are obviously able to distinguish a lot of you know, faces that overall look similar, and we can associate them with different you know, individuals and so on and so forth. So this is a very, very old question, whether you are born with that ability or it is something that just develops over time, like vision, you know, like everything else almost in the brain, develops over time. You need that input early on in life in order to build these networks and have them mature and so on and so forth. And for some reason, most people have thought that this is actually inborn, and we are born with that ability. And there was some evidence for that as well. So for instance, you know, babies, infants can recognize their mothers very early on, very, very early on. How can that be, right? And there's no really, really good evidence from research that has been done in baby monkeys that face perception develops just like all other visual functions, and it develops by input. And if you don't have that input, then you will not be able to, distinguish faces very well. The interesting thing, though, is that there is a network of regions that is specialized in the brain, in our visual parts of the brain, that is specialized to process face information. And if these regions do not get that input, but get something else, then they will specialize on whatever else that is. So I give you this example in these studies where baby monkeys were raised without facial input. So basically the caretakers would just, wear masks and so on, so that, they did not have that facial information. The interesting observation was these caretakers all were wearing gloves. This is just, a hygiene measure, basically, just like, nurses in hospitals wear gloves too. So that's normal in that research, but it happens that these gloves were blue. So they were wearing blue gloves, and all what these face regions were specializing on later on were blue gloves, because that was the input during that period of time. And that was kind of interesting. So it's not that these networks, if they don't get the right input, if you like, they are just sitting there doing nothing. They are just, doing whatever kind of input they had. And so that was a kind of an interesting thing that came out of these studies, that face perception develops depending on input. And if you get other input, then you represent whatever that input is, even if it's, blue gloves that has nothing to do with the face.
Yeah, that's also like I really like how like this, I don't know, that's kind of surprising to think about. Like they just registered the blue gloves and nothing else. So my last question would be, what I admire about you is that you started a program called the Frontier of Minds, and you got an award from it, and it's been like, something really big, and you inspire kids to review and understand scientific papers, and you go to the Riverside Elementary School in Princeton, New Jersey, and expand the interest of students in topics such as brain evolution. And you want your program to have students say that, I've heard about the brain through the Frontier of Minds. And what does like Frontier of Mind mean to you personally?
So Frontiers for Young Minds, and you can Google it. That's an open access online journal for kids like you who are interested in the brain, but it has also other science information. So we have, I think, 6 sections now, ranging from mathematics to space science. There's a health science, and there's neuroscience, and probably a couple of other science sections that do not come to mind right now. But we started it about 7 years ago in 2014 as a neuroscience journal initially, and then the other sections were added on here. And the overall idea was to produce a journal where the latest science is reported to kids in a way that kids can understand it. And in order to make sure that the articles that scientists would write for kids, based on their latest discoveries and so on, could be understood by kids, could be comprehended by kids, and digested by kids. We asked the kids to be our reviewers. So the kids get an article that's written by a scientist, and the kids give us feedback, what they think about the article, whether it's written well, whether it's illustrated well, whether it's interesting or totally boring. I mean, whatever they think. And this was the idea, and this is basically what we have done. We have published in the neuroscience section probably close to 200 articles ever since. So this is all volunteer work. It's all scientists who are just engaged with this initiative, who volunteer their time to write these articles. I have written a few myself, And then again, we have our kid reviewers who help us evaluate that before we publish the articles online, and everybody can access them. We translate now Frontiers for Young Minds articles into major world languages. We started with Hebrew and Arabic, but we work now on a Chinese translation, on Portuguese, Spanish, French, and there will be probably other, languages over time. So it started at the end of 2014 with, I think we had 6 clicks, so 6 views. And we were just hitting the 10 million mark very recently. And we have reached children and teens and so on, young people in all countries of this world. There's not a single country in this world that did not have, where we did not have views for Frontiers for Young Minds. So I think this is one really beautiful thing. This is an initiative that has no borders. Unfortunately, even in our world, there are still a lot of borders, but science as a field has no borders and should never know borders. And Frontiers for Young Minds is an example for that. We try to reach children everywhere, to educate children if they are interested in sciences and in the brain, and in the case of the section that I'm overseeing there. And I think this has a potential to have a huge impact on science education of many, many children around the world. And so I think, I hope for the day when a young student who is applying for graduate school will come into my office to interview for graduate school and tell me, and if I ask the student, how were you introduced to the brain? The answer will by Frontiers for Young Minds. That would make me really, really proud. We are probably not there yet because we are not there long enough, but I do think it's it's an education initiative that is unparalleled, and I hope that other people will get inspired to follow if they are adults, and I hope that we can inspire just many, many children to become scientists. Science is just so fascinating, and my feeling is that it's often not taught very well in schools. Some sciences like neuroscience are actually never taught in school, or very little, here and there, bits and pieces. And it's a shame because science is just fascinating to many, many young people, but you do not have the opportunities. You, Rachel, seek out these opportunities, but many other kids probably don't have that initiative, or they don't have the opportunities, but they can still go to the website of Frontiers for Young Minds and try to get information on something that interests them. And so I just hope that we can, inspire kids to become the next generation of scientists, and, probably can even become a tradition that, scientists are inspiring the next generation in that way. So that's kind of where our ideas behind it. And we just have had a blast. When I started it, I was probably a little bit worried that it could take too much of my time. And looking back at, what we have created there, I think that every moment I've spent on Frontiers for Young Minds, I got back in many, many rewarding ways, just listening to what kids had to say about the journal, what other colleagues are saying. It really has become a community of, I think, idealistic scientists and educators who just want to inspire. And I think to some extent, we have done that. So spread the word about Frontiers for Young Minds. I think it's pretty cool.
Yeah, that's what I was gonna say. Viewers, please check out Frontiers of Mind. Please support Professor Kastner and tell your siblings about it, tell your family about it, and inform the young generation about Frontiers of Mind because we need more people to know about neuroscience. And neuroscience can impact all different types of fields. It's not just science. So please check it out. You can improve yourself knowing more about the brain. So
Yes. Can I just say one more thing about that? It really can help you to understand yourself better. If you want to learn about memory, why you learn better if you have a good night's sleep. I mean, you can learn about so many things that are really relevant to your life, and you will understand why that is, and probably then also be a little bit more careful with what you're doing. So I think it's really, really cool thing to start to understand what's going on up there.
yeah, definitely. And check out brainfacts.org too. Professor Casey and Professor Kastner both work at brainfacts.org. So please check out all the interesting information to learn more about the brain. And I would just like to thank you once more, Professor Kastner, for coming on and agreeing to speak with me today. I learned so much information about your research in regards to like the curve and how we can sustain our attention and have breaks, because I talk about that in my videos a lot. Take breaks, and you heard it from Professor Kastner here. She recommends taking breaks, so make sure to take breaks for full success. And I thank you so much. Your research really impacts so many different people, and I hope that I wish you success in everything, and with the research to continue to help the young generation. And thank you so much.
Thank you for having me, Rachel.
Okay, bye everyone. Hope you enjoyed this video. I'll see you next time in my next video. Bye.
Bye, take care.